So as you see on the left here, these are the decibels, minus 60, minus 40, minus 24, all the way up to 0 dB. And if you know for recording applications, 0 dB is kind of the highest you ever want to go. If you go above 0 dB, then you're going to start clipping. So looking at this wave here, you can see that the big part of the wave is on the lower end of frequencies because my voice is generally deeper and I'm not, I don't have like a sharp high pitched voice. And that's why the high end is kind of curved down. And the mids, as you see, are kind of synchronized with, actually a little bit less. If you look at it here carefully, the mids are staying a bit low while the highs are generally jumping a bit higher than the mids. So that's generally kind of like one of the common things they do. Like they say like this is the shortcut to great audio is you increase the lows, increase the highs, and cut the mids. That's just generally what they say. Most PA speakers, or anytime you go and get like a consumer-based speaker on the market, they will be pre-built to cut the mids, increase the lows, increase the highs, because it just makes a more heavy and rich and clean sound. And it cuts out all that muffly, muddy mids. So that's what they say, but as you see, it practically works. And one of the reasons it works is, you're making me think of another thing here. One of the reasons it works is because it's how our ears collect. It's how our ears tune and receive frequency. So I'm actually going to stop sharing my screen for a second. I'll get back to it. All of this recording is not going according to plan. Every time I'm recording, it's like jumping off of what I wanted to talk, but it's good because I have to address these things. So let me just pull up my diagram here because I'm just in the topic right now talking about the spectrum of frequencies. But I wanted to talk about the 3DO binaural microphone, which I talked about in the previous recording, which is able to capture the environment of a room. So you can have like these pre-recorded environment captured sounds. So you can create your environment, you can create your depth of field or your dimension of space and have those pre-recorded dimensions available. So when you take your 2-channel stereo and add it to that dimension, you can simulate an environment for your produced sound. But getting into that, there's a certain microphone that captures that environment, which is the 3DO FS Pro 2 binaural microphone, and it's shaped in the form of human ears. But there's a good reason why it's shaped in the form of human ears. And I was just going to talk about that graph for you right now because we're talking about the spectrum and why the mids are recommended to be cut out and why it generates more sales for speakers that are sold on the market that have these pre-built EQs in them where they increase the lows for the big boom, 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 and they have the highs for the nice, sharp, clean sound, but they cut out the muddy mids. Let's see if you can see that. So as I was going through all of this, you can see here's the graph, and up here, here's the frequencies. And I basically flipped this around. So if you look at the original graph, here's the original graph. Do I have this upside down? I do. There we go. Sorry, I had it upside down. Camera tricks. The camera is playing tricks on me because as I'm looking at the camera, it's showing it backwards. So, okay. So here, as you see, these are the frequency hertz, the spectrum. And what does the spectrum mean? A spectrum means the graph. So spectrum means like from here to here. So the spectrum of 20 hertz all the way to 15 kilohertz, the spectrum of this graph, there are many frequencies within that spectrum. Now, all these frequencies within this spectrum of 20 hertz to 15 hertz, kilohertz, you have all these different hertz as it goes down to the lower frequencies on the spectrum. And then on the right-hand side here, you see here's the decibel level. And these decibels are in sound pressure decibel level. So you have different kind of decibels. You have recorded decibel, and you also have sound pressure decibel, which is what we hear naturally in the human ears, with projected audio, not recorded audio. So with this, what this wave is this is a study that has been proven on how our ears capture the decibel of sound. So when you're looking at this here, you're seeing that on the 20 hertz of decibel at minus 50 dB, this is how our ears will hear the sound at minus 50 dB. And if you look at 10 dB, in order for us to hear 10 dB of sound, we'll hear it at 80 hertz. That as you go down, our ears generally don't hear all these lower frequencies once you get down to 20 hertz. So our ears are less sensitive to hearing these sounds, but they're more sensitive in the decibel. See the decibels increasing. Our ears are more sensitive as the frequency goes up, but then you see it drops, and then it goes up, and then it drops, and it goes up as it gets to 15. So it's not like all these frequencies, we hear it at that decibel perfectly for all of them. No, we hear frequencies differently at different decibels. So with this, it makes it very tricky for a sound engineer. Sorry, you couldn't hear me because I was speaking behind the mic. But it's good I have a supercardioid, because then I was able to speak behind the mic and you could still hear me a little bit, rather than just a cardioid. If I had just a cardioid, you wouldn't be able to hear me when I was speaking like that. So we hear decibels differently we hear frequencies differently at different decibels. It's not that if I turn something up to minus 10 dB, that you're going to hear the entire frequency spectrum at that minus 10 dB. Some of the frequencies you'll hear louder than others. So what this means is you might hear 800 hertz at 110 dB, and you might hear 20 hertz at minus 30 dB. So this makes it very complicated for sound engineers, because as our human ears naturally hear sound and frequencies at different decibels, you'll need to adjust the threshold of those decibels so that the sound of the dB will be consistent for each of those decibels, so that it sounds naturally. So as I was embarking on this study and trying to figure out why do sound engineers create all these different EQs and presets of EQs for people, when our ears also have their own natural EQs in them to receive the waveform of sound the way we hear it in our natural hearing, and add a synthetic equalizer on top of our natural equalizer, just distorts that sound even further to where it sounds completely unnatural. And that's what I was looking at, and I'm saying, you know what? Here's another graph of our ears right here, and it shows the dB and how our ears take sound and it records it in a spiral, and different hertz of that sound is recorded in different lobes of our ears parts and at different decibels. And it's just amazing how intricate our ears are designed to receive that sound and to filter that sound and to hear it in the way we hear it. But as you see, because of that, and in green here, as you say, normal conversation is at 60 dB. So you see, normal conversation is at 60 dB. So if I'm listening to 20 hertz at 100 dB, if I'm listening to 40, let's say, for example, where is it here? Let's say if I have 1,000 hertz right here, 1,000 hertz at 60 dB, then in order to hear 20 hertz at that same dB, I will have to increase it to 110. Or was it 100? No, we're at 60 here. So 60 is 100, yeah. So I'll have to, if I'm listening to 1,000 hertz at 60 dB, because you see here it's on the graph, 60, 1,000 hertz. In order for me to hear the same 60 dB of 20 hertz, it'll have to increase to 100 dB. And then, if 20 hertz is increased to 100, it'll be the same as hearing the 1000 frequency hertz at 60. So understanding this, I had to take the graph of how our ears are equalizing sound. And then from this, I was then adjusting the frequency on Ableton. Now let me go back because I just showed you all this graph here. So this graph is inverted. It took me a long time to figure that out. Kind of funny, but yeah, it took me a long time to figure out that this graph is inverted. And I said, okay, well, I have to invert the graph up here, right? I have to invert it if I want to implement this into software so that software can simulate that sound and reduce and increase the decibels so that when I put on headphones, it'll sound like I'm not wearing headphones. It'll sound the way I hear it without headphones. And that's how we want to hear sound. We want to hear sound natural. We don't want to hear sound artificial or synthetic. So that was one of the researches that I've embarked on as a sound engineer or an 8-dimensional sound engineer. And what that practically looks like, let me get into share screen here. In Ableton, oh, 1 second, share. What that practically looks like as you're looking at the decibel here, because I was able to equalize the sound, right here, you see the graph right here, I was able to equalize the sound to match similar on this one channel. Now I could equalize the sound to sound naturally in one channel, duplicate it to another channel, and have a different one, and have a different one. So I can create a really artistic, natural sound in this spectrum, so that, as you see the way I preferred it to sound like, I want the lows to sound super rich. And I want the highs to come in clear so it doesn't sound muffled. But I want to cut out all that muddy, scratchy huskiness of the voice, because that's the type of voice I have. So I want to cut out all that muddiness of the mids, but also keep it clean. Now you have speakers that have all this pre-built into it, but you don't have a way to customize it, and they have like presets. So if I was going to adjust the mid or the highs or the lows, it just is a general adjustment, but not to a precision of pinpointing it down to what frequencies on that spectrum do you want to reduce or eliminate, and what frequencies do you want to enhance. You can't do that on a general dial. A general dial will create like a bow, like a wave that will bend the frequency, but not to a point where you can cut out specific frequencies and add multiple bows and bends to create a really limitless curve of the frequency. And that's what software is able to do, where hardware doesn't have that flexibility. So you can create like a somewhat EQ of vocals with a hardware analog, but when you go digital, you can EQ it with precision. So that's what I wanted to share briefly, that I was basically embarking on a study to learn how our ears equalize sound and take that human ears EQ, because there is an EQ of our ears. And rather than creating like hip hop or bass reduction or monotone or all these different synthetic pre-made EQs that are already out there, I want the natural human ear EQ added to software. So I was embarking on that study, and I pretty much almost like 80% accomplished it. And it's going to be very exciting once I accomplish it, because then once it's accomplished, I'll be able to have these headphones on, take them off, put them on, and I won't even hear a difference in the sound. It'll sound the same whether it's on or whether it's off, like it's recorded like in a natural sound environment. And that's pretty darn incredible. So that's basically explaining what the spectrum is. Now, what I wanted to, why I introduced this spectrum to you, why I actually wanted to talk about the spectrum, was not about this. This is just an extra thing I just kind of threw in this lesson here. But why I wanted to talk about the spectrum is because of the 3DO microphone. and how it captures the environment of sound. And the beauty of what that can do for sound engineers. One of the things sound engineers use right now is they have this device, this little tiny microphone that they use to squelch a room, and they say, okay, let's put some white noise in the room and let's see where the feedback is coming from and how everything is equalized in the sound of the room. But they take these microphones, they can often use them with their iPads and these traditional stereo mics. But the beauty of using a binaural microphone that captures sound the way our ears hear it, you can equalize the sound of a room naturally. And one of the great benefits of that is that you can tune a speaker with precision, whereas before you would tune it with synthetic audio. So that's one of the highlights, and I was going to show you the microphone here. I can just kind of bend it over and show it in the camera. Let me just stop my share for a minute. It's on a long stand here. So as you can see, there's the microphone right there. And both sides are shaped like this human ear. And it takes in the sound of wherever you're recording, and it filters that sound in the way our ears filter it in. So it's capturing the sound into high precision capsules, which are omnidirectional condenser mics, which are generally used for recording. So you wouldn't use this microphone for like projecting audio. It's not like a handheld mic that you use on a stage. It's for recording audio. But this microphone can record high precision, high quality, high fidelity, lossless audio of binaural 3D audio of an environment to capture that dimension of sound of that environment. And it's really great because both sides have both ears on it. And it captures that sound. But what this can do with Ableton, I was amazed. Let me flip this off. Oh, there we go. So what that's able to do with Ableton is I'm able to plug it in with Ableton. If I add a spectrum filter like I just showed you. Now, if I had my 3DO microphone plugged into Ableton, and you would see it here, and I added the spectrum to it, because that microphone captures every sound with precision, the way our ears hear it, you'll be able to see the frequencies with precision to know which frequencies are really causing the problem. It's almost like someone, how do I say it? Okay, it's almost like having someone trying to come into a room and say like, can you put earplugs in and then now tell me, okay, I want you to go listen to this, I want you to listen to this song and I want you to tell me what needs to be adjusted with it. But while you're listening to the song, before you put on your headphones, go put some earplugs in and tell me what needs to be adjusted with my voice. Do I need to increase this or decrease that? Is it too loud? Is it too heavy? Do I need to make it a little bit more high toned? And you tell this person to listen to the sound, and then you tell them to put earplugs in first before they put earphones on. And they're hearing the sound, and it's all like, and you're like, so how does it sound? And they're like, yeah, it sounds a bit muffled, but you can probably increase the highs quite a bit. But the highs didn't need to be increased because the reason it's muffled is you got earplugs in. Common sense, right? But that's what, ironically, sound engineers have been dealing with for a long, long time, because they're using these audio capture source microphones that have a limited range of spectrum of frequencies that they're able to capture and not capture it with precision the way our ears capture sound. And they're trying to take that and then try to find out which frequencies are causing problems, and then has to adjust the mids, the lows, the highs, and try to balance and equalize everything. So they've been doing a pretty good job with what they've been given, but now with the 3DO microphone that captures in high quality precision, is able to show you that spectrum of graph, like here, and show you which frequencies are problematic and which frequencies need to be adjusted. So this can help you balance the EQs of a room just by that microphone. So that microphone is is not just great for recording spatial audio of an environment as a binaural microphone, but it's a great tool to be able to squelch a room. So I was pretty excited about that as a sound engineer. I said, wow, this is a very powerful tool. Just even that alone is a well-paying job. To say, you know what, I'm going to come in with natural 3D microphone capabilities and just equalize the sound of your room to make everything sound more natural for you. So that's pretty good, but that's what I wanted to share briefly. Where's my Zoom here? I want to make sure I'm still on the Zoom call. And I've been showing my face the whole time. So I don't know. I thought I was sharing my screen there, but let me go back to share my screen. Share desktop. There we go. So yeah, thank you for listening. And that's a brief touch up on some of the amazing things that I've been embarking on studying and looking into, and the researches and things like that. And the 3DO microphone and its capabilities. Things I've been testing is, I didn't really mention, but the 3DO microphone is able to capture an entire environment of a room with natural audio because of, like I told you, I've been studying the graph of the EQ of the human ears and implementing that into Ableton. I do have a 3DO chart on here, and it shows the graph for the human ear EQs, and it's about 80% complete. I'm not displaying that before you today. I'm displaying my Super 55 dynamic mic for you, but I have an Ableton template for my 3DO mic, and I'm almost 80% completed that template. And once it's completed, it's going to be incredible. But another benefit of that microphone is you can take it into an environment and capture a meeting of an entire room of people, like 50, 60 people, and it will record the sound the way you hear it if you were sitting in that room and joining that meeting. And you'll hear, like, okay, someone's talking on my top, someone's talking 5 feet away from me on my right, someone's talking 3 feet away from me behind me, and you'll be able to hear like 50 people in 50 different positions when you put on your headphones. Okay, let's say I took that microphone and I placed it in a room that was 15 feet by 15 feet. You'd be able to hear it like you were in a room 15 feet by 15 feet, or you'd be able to hear it that you were inside of a big open field or a park. So that microphone captures the size of the room and all the positions of the source of the audio is within that room. So when I put on the headphones, it would be like I just joined that meeting. And I was there at that meeting to hear it the way I would have heard it if I was there. So the benefit of that, though, is to be able to capture all the input sources in an environment where it makes it very challenging to. For example, if you got a group discussion happening, it's very challenging for a sound engineer to be handing a microphone, telling everyone, wait, please don't speak, raise up your hand, and I'll bring a microphone to you, and then you can say your input. And then you have someone running like a marathon back and forth, handing microphones to people so that they can all take turns speaking. And when someone has 1 or 2 words to say as a comment of what someone else said, you don't get that in your recording because you weren't quick enough to give the mic just to hear them say, oh yeah, that's right. So in order to capture everyone speaking, and sometimes people will speak without waiting for a mic, in order to have no loss of audio, you have to be able to capture all that sound in that room. So this microphone has that ability to do that, where it eliminates that headache of having to hand a dynamic handheld mic to each of the people speaking in the room. That's one benefit. So you can just set it up in the room. You don't even need speakers. You don't even need PA speakers. You don't need anything. You just bring the microphone, bring a laptop, set it up in the room, and just record the entire thing. And you'll be able to hear everyone in the room speak clearly, as if you were there in the meeting, listening. So that's an amazing benefit that the 3DO microphone can do with Ableton and the power of Ableton.